Today we continue with the topic on coastal littoral processes. We remind ourselves that the coastal profile is dynamic, which means that it undergoes changes, especially the beach profile, which is under active action of the current, the waves, and even the surge of water going up and down the beach face. All these processes contribute to the profile changes, and it is very complex to consider them together, which is why usually we will break them down and look at the effect of the individual processes. Other than that, the grain size distribution of the beach plays a very significant role as well, in terms of the stability. And of course, different processes have different relative strength. So the final profile shape will depends very much on the interplay between each and every one of them. In these next three slides, there are some write-ups on the mechanism of profile change. Right now, let's look at the coastal profiles. We have three figures here, which we will look at one by one. The first one is the beach profile, the second one, the nearshore profile, and the third one, the intercontinental shelf profile. For each of the figure, we have the vertical scale and also the horizontal scale. This horizontal scale here shows 0 up to 9,000 meter. But take note that when we apply this scale to each of these figure, we apply it slightly differently. When we apply this scale to the first figure, we divide it by 100. So 0 is still 0. 9,000 divided by 100, we get 90 meter. So this part of the beach is about 90 meter wide. But when we apply the same scale to the nearshore profile, we divide it by 10. So if this is assuming this point mean sea level here is 0, but on the scale it is at about 150 is about 150 meter because we divide by 10. Here divide by 10 will be 900 meter. So 900 minus 150, so the distance from this point to this point is about 750 meter. When we apply this scale to the third figure, we apply as it is. So the distance from this point, the mean sea level, up to this point is 9,000 meter, which means 9 kilometer. Now let's look at the beach profile. So we have a beach which is about 90 meter wide up to this point. But if we look at the beach up to the point where the mean sea level is about 75 meter. We have a cliff or dune at the back shore here, which is about 10 meter high. We have a fairly wide foreshore, which is about 60 meter wide. This mean sea level is next transferred over here in the figure for the nearshore profile to allow us to look at what is the profile like below the water. So we see that on the sea side, the water depth dropped to about 5 meter deep over this distance of about 150 meter. And after that, we can see a longshore bar, which is formed from broken waves, as we discussed previously. And further seaward, the nearshore profile continued to slope downwards and reach about 10 meter deep at a distance 150 meters away from the shoreline where the mean sea level meet the beach. If we zoom out further, so that the mean sea level now is plotted at this point, we are looking at the intercontinental shelf profile, where the seabed has a concave shape which is fairly smooth, and it goes all the way down to 30 meters deep at 9 kilometers into the sea. The nearshore profile just now is basically this part here at less than 10 meters deep. So when we zoom out, we may not be seeing the longshore bar in the intercontinental shelf profile. On this slide, let's look at how the beach profile responds to a storm event. On the top here, we have the wave height in meter from 5th of October 1981 until 16th October 1981, which is a period of approximately 11 days. We notice that the wave height is in the order of 1 meter, but increased to 3 meters in storm 1, increased to 2 meters in storm 2, increased to 3 meters in storm 3, and up to 4 meters in storm 4. As a result of this series of storm events, the beach profile has changed, and the measured profile are given in these three plot here. In the first one, we have the comparison of the beach profile on 5th of October before the storm events, and 17th of October after the fourth storm. So based on the dashed line, we can see that initially there is a longshore bar close to the shoreline, and this line here represents the mean sea level. As a result of the storm events, we notice that the longshore bar has been pushed seawards, and it has steepened closer to the beach. The longshore bar has offset by about 40 meters in distance. The total material loss in this region enclosed by this old and new profile is estimated at 80 meter cube per meter length of the shoreline, whereas the area here enclosed between the two profiles is estimated to be 50 meter cube per meter. So essentially, there is a loss of 80 meter cube here and a gain of 52 meter cube here, meaning that there is a net loss of 28 meter cube per meter length of the shoreline, and this loss is likely to be lost to the offshore region beyond the breaker point. So this is what happened before and immediately after the storm event. Next plot here compares the beach profile on the 17th of October, repeated here, with the beach profile on the 2nd of November, which is about 2 weeks later. We notice that there are further changes to the beach profile. The wave height is not shown. Basically, this is a period of recovery. There's no more storm. So we can assume that the wave height returned to its normal condition, which is in the order of 1 meter. So during this 2 weeks period, we notice that the longshore bar has continued to migrate further due to the disturbed dynamic equilibrium. And as a result of that, the crest has displaced by 54 meters. We have a steepened near shore beach profile that has recovered with a gain of 28 meter cube per meter. We have a loss of 41 meter cube per meter here and a gain of 52 meter cube per meter. Overall, there has been a gain of 39 meter cube per meter. Next, if we compare 2nd November with 16 November, which is another 2 weeks later, then we notice that the same longshore bar has been displaced further seaward again by 78 meters. The part close to the shoreline here has recovered further, but that's actually due to the loss of the beach area above the mean sea level line. This is happening because right now the mean sea level has protruded further landward, and it allows the incoming wave, although it's a regular wave condition, it allows the incoming wave to erode this part of the shoreline, which previously is much further away. And the erosion here contributes to the recovery of this part of the profile beneath the water surface. And actually, this is going to continue to grow and eventually is likely to form the new longshore bar, whereas the existing longshore bar is likely to continue to push seaward and eventually become smoothened out, like what happens at the beginning. So this basically is the natural recovery process, showing that the beach profile is dynamically changing according to the condition, the weather climate, the coastal climate. This is another set of figures showing the evolution of the beach profile post-storm, that means after the storm event. We see here from 21st July 1970, the changes on a day-to-day basis until 30th July 1970. What we notice here is that there is a longshore bar which is very wide, and the longshore bar has becomes narrower due to loss in the part nearer to the offshore point, and eventually lead to accretion at the beachfront and the formation of a new longshore bar. All this happens just over 1 week time period only. This figure shows the changes of the beach dune, which is above the mean sea level. So this is the profile of the beach dune on the 29th of May, and its changes all the way up to 7 September. The figure also shows the mean low water line. We can see that the beach dune has evolved, although not very significantly here, because this is likely to be the last dune, which define the limit of the littoral process on the landward side. But we can clearly see that the foreshore part has undergone changes dynamically over the period, and all these are changes after a storm event, which shows that the beach profile is adjusting to the new condition in order to establish the new equilibrium.